So we're going to go ahead and take a look at the quadratic formula. That's a special way to solve quadratics in a fairly efficient way. It's not my favorite way to solve quadratics, to be honest, but it is actually a very good way, and it's one that you should be familiar with. And so we're definitely going to take a little bit of a run at this. I wanted to look at this problem in two different ways just so that you can see how this works, and then we will emphasize what we want to do. So the first thing is I want to remind you how we have done this problem previously. The first thing that I would like to do when we solve this quadratic is move this 6 across and look at it this way, and see if we could maybe factor it, because that's, again, going to be my first method of attack. Is can I come up with two numbers that multiply to a times c, which is 24, and add to negative 12. And so when we think through 1 and 24, 2 and 12, 3 and 8, 4 and 6, none of those numbers, again, 1 and 24, 2 and 12, 3 and 8, 4 and 6, none of those numbers that multiply to 24, and they don't both have to be negative, by the way, but there's no way for me to get the negative 12 out of that. So factoring is going to fail. So I'm going to go ahead and say no to factoring. So the second thing that we learned how to do is we learned how to solve by completing the square. Completing the square. So that's the way I thought I would start this particular story. So when we solve by completing the square, the first thing that we've talked about doing every time is clearing out a little hole that allows me to complete that square. I want this number right here to be a special value that makes it work. So we do our little cut in half and square story. So keep in mind, when I take negative 12 and I cut it in half, I get negative 6. That's the first part. But remember, it's cut in half and square. So I get a plus 36 here and here. Remember, if we add the 36 to one side, we must also add it to the other side. Now, this is my favorite way to solve a problem. Oh, actually, that's not an 8. That's silly of me. That's a 12, isn't it? But now that we have this nice perfect square, we could take the square root of both sides. And keep in mind, if you take the square root and the square, they cancel each other out. So that's what happened here. But remember, every time you take the square root of both sides, you get a plus or minus. A plus or minus on that 12. And the only thing left that I would say that we need to do is we could break down this 12 as being 12 is 2 times 2 times 3, isn't it? If you did a little factor tree, because 2 times 2 is 4 and 4 times 3 is 12. And so we have a pair of 2's. So we have x minus 6 is plus or minus 2 roots of 3. And then if we brought the 6 to the other side by adding it to both sides, we would have x is 6 plus or minus 2 roots of 3. Now, one of the beautiful things about math is that sometimes we can look at problems through a variety of lenses, but they should all come to the same conclusion, even if the work looks differently. So what I wanted to do is take a look at this step of the problem right here, and this is very important that you have it set equal to 0. If it's not equal to 0, we have to do that, okay? And so we are going to say that A is 1, B is negative 12, and C is 24. Sorry if that doesn't look like a negative on that 12. And we're going to use this formula. Now, the only thing about this formula that I don't like is, well, I guess there's two things that I don't like. Number one, it's a big formula, and if you make a mistake in there, boy, you're going to have troubles. But the second is it has a lot of order of operations that we have to really honor. And if we make a mistake in there, we're going to end up having an issue, of course, because that's been our story all the way from, probably about third or fourth grade when we first started seeing PEMDAS, right? So the formula says, let's take the opposite of B. So since B is negative 12, I'm going to write down positive 12. There's a plus or minus here, just like there is in the original problem. I'm supposed to take this negative 12 here, and I'm supposed to square it. I'm going to get 144. Now, here's where we get ourselves into a little bit of hot water sometimes. Minus 4 right here times A times C all over double what A is. Now, that's not too bad, I'm going to grab a calculator real quick because I don't have that on the top of my head. But if I took 144 and I subtract 4 times 1 times 24, I got the number 48. Okay, so it's 12 plus or minus root 48 over 2. Now, this is not exactly what we have over here, but it should be. But I have a larger number. See, I had a root of 12 before, and now I have a root of 48. So let's see. 48 is actually 4 times 12, and 12 is actually 4 times 3. So you'll notice that I had a pair of 4s. If you did that factor tree differently, you could have 2 pairs of 2s, but I chose to find a pair of 4s instead. So I have 12 plus or minus 4. Remember, pair of 4s, roots of 3 over 2. And you'll notice since 2 goes into 12 6 times and 2 goes into 4 2 times, we end up with exactly the same story right here. Now, if you compare the length of these two problems, it's pretty clear that they're fairly similar in length. I actually believe personally that this was a little clearer, so that's why I actually try to encourage my students to go completing the square if the problem is easy. And what I mean by easy is if A is 1 and B is an even number. Because if A is 1, it's easy. If B is an even number, it's super easy. So that's why this problem came out nice. My example number 2 is a little rougher. This one, option number 1, is absolutely doable. And in more advanced classes, I would absolutely encourage you to go that way. But for the moment, I want you guys to learn how to do this. So the first thing is I need to subtract 5 from both sides because I must set the thing equal to 0. And then I need to identify what A is, what B is, and what C is. Now, I'll be honest. I set this problem up and I don't really know exactly what the answer is going to be. We're going to see. So my formula says, and it's always a good idea to write your formula down so you don't make a mistake here. And it does take a minute to write it down, but it says we're going to do the opposite of B, which is 13. We're going to square that. And by the way, since you're squaring it, this number right here will always be a positive value because I'm squaring something. And then 4AC all over 2 times A. Now you'll notice that I actually write down a lot of those things without using my calculator because I see people all the time do this. Negative 13 squared is negative 169. But the mistake is it should have been negative 13 squared. Because I'm not squaring part of that negative 13. I'm squaring all of that negative 13. Well, coming over here, 169 minus 4 times 6 times negative 5 is actually 289. Well, as it turns out, the square, so I've got 13 plus or minus the square root of 289 over 12. Now, again, of course we can do a factor tree, but sometimes let's just have for curiosity, what happens if I try to take the square root of 289? Maybe it is a nice number, and it turns out it is a nice number. So I got 13 plus or minus 17 over 12. Now that looks terrible, but let's just see what happens. What is 13 plus 17 over 12? Well, that would be 30 over 12. Those are both divisible by 6. So one of my answers is 5 halves, or 2.5. Or x is 13 minus 17 over 12. Well, 13 take away 17 is negative 4. Negative 4 divided by 12 is negative 1/3. So those are the two answers, which, because those are nice answers, tells me my problem could have been done using a diamond and factoring method. Now, not everybody likes to do this, but I do. See this 2.5? That's a pretty nice, easy number. So I'm going to go back to my original problem, and I'm just going to make sure I didn't do something silly. So I'm going to take 6 times 5 halves squared minus 13 times 5 halves. Now, if I have done this problem right, according to my original problem, I should have the answer 5. And I did. So that does tell me very quickly that I did the problem right. And if I wanted to, I could go back in here and highlight it, and I could change each of these numbers to -1/3. Unfortunately, I guess I pushed things over a little too far. And I also get 5. So that's a nice, easy way to make sure that I can check those answers. So sometimes you get answers that have radicals in them. Sometimes you can find answers that you get lucky and it was actually nice. And like I said, we could have solved this problem a little bit differently if we used a -15 and a 2, done a diamond problem. Remember, that would be 6x squared. -5 goes here, -15x goes here, 2x goes here. That kind of problem that we've done a whole lot of, that's going to be 3x in common times 2x, 2x times 1, 3 times -5. And all of a sudden, what pops out of our story is the answer +5/2 for this one and -1/3 from that one. So again, lots of options to solve on quadratics. I think factoring is by far the easiest, but the quadratic is nice because it just works whether the problem is a nice, easy solution or whether it has a radical in it. It just gives us good answers. So I think I will stop there. Hopefully that was helpful. I'll see you back in class. Bye-bye.